The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All righty, so today we are going to cover section 8.9 and also assign the chapter review. But first, I have a problem that somebody wanted me to do, so we'll start with that. Okay, so this is from section 8.5. Actually, there's two problems we're going to look at. The first one is number 9. It says, solve the equation. And we have the absolute value of the quantity x minus 7, and then minus 16 equals 7. So to solve this absolute value equation, the first thing we want to do is isolate the absolute value term. So we're going to start out by adding 16 to both sides of the equation, which gives us this. Now we'll break it up into two separate equations. X minus 7 equals 23, or x minus 7 equals the opposite, or negative 23. Solving the first equation, we'll add 7 to both sides of the equation. X equals 30. Solving the second equation, we'll add 7 to both sides of the equation. X equals negative 16. So we get 30 and negative 16. Let's check our answers. If x is 30, we're going to have the absolute value of 30 minus 7. Minus 16 equals 7. 30 minus 7 is 23. The absolute value of 23 is 23. 23 minus 16 equals 7, so x equals 30. Checks. Now let's try negative 16. We would have the absolute value of negative 16 minus 7, and then minus 16 equals 7. Negative 16 minus 7 is negative 23. The absolute value of negative 23 is 23. So again, we get 7 equals 7. So our two answers, x is 30, x is negative 16. Any questions on that before we go on? Okay. The next one up is also in 8.5. This is number 17. Again, it says solve the equation. Here we have the absolute value of the quantity 4x minus 3 equals the absolute value of the quantity 3x minus 25. We have an equation containing two absolute values and just that. So we want to separate them, one on each side of the equal sign. It's already there. So one of our equations is going to be what's inside of the first equals what's inside of the second. And the other one is going to be what's inside of the first equals the opposite of what's inside of the second. Notice I put parentheses around the 3x minus 25 on the right side. We're then going to distribute that negative eventually. Going back to the first equation, I'll subtract 3x from both sides and get x minus 3 is negative 25. Adding 3 to both sides, I get x equals negative 22. The second equation, or the one on the right, the left side doesn't change. Distributing the negative sign, we get negative 3x plus 25. Then I'll add 3x to both sides of the equation. 7x minus 3 equals 25. I'll add 3 to both sides of the equation. 7x equals 28. Divide by 7, x equals 4. So let's check our work. Let's take the negative 22 and put it there and there. So we get the absolute value of 4 times negative 22 minus 3 equals the absolute value of 3 times negative 22 minus 25. 4 times negative 22 would be negative 88. Negative 88 minus 3 would be negative 91. The absolute value of negative 91 is 91. 3 times negative 22 is negative 66. Negative 66 minus 25 is negative 91. The absolute value of negative 91 is 91. We get 91 equals 91, so x equals negative 22 is a correct solution. Now let's take a look at x equals 4. So we get the absolute value of 4 times 4 minus 3 equals the absolute value of 3 times 4 minus 25. 4 times 4 is 16. 16 minus 3 is 13. The absolute value of 13 is 13. 3 times 4 is 12. 12 minus 25 is negative 13. The absolute value of negative 13 is 13. And again, the answer checks. All right, those were the questions that were sent to me. Are there any other questions before we go on? If so, now is the time to speak up. All righty, I'll take that as a no. So now we're going on to section 8.9. The topic is variation. We're going to look at 3 types of variation today. The first type is called direct variation. Direct variation in general can be written in the form y equals kx. X and y are the variables. K is what we call the variation constant. What's going to happen in these problems is we'll read a sentence or a story. It will tell us what kind of variation we're using. It will give us some information. We'll plug that into a formula to determine what K is. It will be some specific value. Then, once we've plugged that number in, we'll have a follow-up question. So let's see here. Here's this first question. It says, free fall. An object in free fall, in other words, it's being dropped and it's just falling to the ground, travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet in 8 seconds, how far will it fall in 10 seconds? All right, so we've got our variables. S is distance, and let's see, t is time. It says an object in free fall travels a distance s that varies directly to the square of time. So s varies directly to the square of time. Now, I neglected to mention this, but I will mention it now. K, the variation constant, is going to be in all of these formulas, but it's not always mentioned. We just have to know that it's going to be there. So distance varies directly as the square of time. We still have K inserted into the formula. All right. Any questions before I proceed? Okay. Now, it says, if an object falls 1,024 feet in 8 seconds, so the distance would be 1,024 feet, the time would be 8 seconds. Notice that t was squared, so whatever I put in the place of t is still squared. This will allow me to determine k. 8 squared is 64, so now I'm going to divide both sides of the equation by 64. Okay, so I've got 1,024 divided by 64, which gives me 16 equals k. So now that is going to go back up here. So now my formula is s equals 16 t squared. So I determined it was direct variation from reading it. I identified the variables. I plugged in some numbers to determine what k was. I put that value in for k. Now, there's a follow-up question. It says, if an object falls 1,024 feet in 8 seconds, how far will it fall in 10 seconds? So now I'm going to put 10 in the place of t. Don't forget that in this formula, t is squared all the way through. So s equals 16 times 100, s equals 1,600. And the units are what? Let's see, it said feet. So there's our final answer. So there's an example of direct variation. Okay. Any questions about that? Let's see here. Oh, I want to point out that in direct variation, as x increases, y increases. So they go up directly. If x decreases, y decreases. So they go down directly. So they move up and down together, so to speak, in direct variation. All right. Second example. Inverse variation. And the general form of that is y equals k divided by x. So again, k, the variation constant, is present, but now our variable on the right side is down underneath. So we kind of have that inverse or reciprocal situation. Okay. This says, this problem, it says organ pipes. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? Okay, so what have we got here? We've got the frequency of vibration. So how about if we let F equal frequency of vibration, okay? And it says it varies inversely to the length of the pipe. L will be the length of pipe, okay? So F is the frequency of vibration, L is the length of the pipe. The frequency of vibration of air in an organ pipe, so that's F, varies inversely to the length of the pipe. So K over L. Again, K is present, even though it wasn't mentioned, and the length of the pipe is down below. So this is going to be the formula we're going to use for this problem. It says, if a pipe 2 feet long vibrates 256 times per second, so that will allow us to determine K. We're going to multiply both sides by 2, and we get 512 equals K. So then that goes right here, and we have F equals 512 divided by L. Again, it says, if a pipe 2 feet long vibrates 256 times per second, how many times per second, so that's the frequency, will a 6-foot pipe vibrate? So we take 516 divided by 6. Let's see here.
Isn't it 512?
Yes, it is. Thank you. I was just looking at that, but you got there first. Good job. Just making sure people were awake out there. Let's try that again. 512 divided by 6. Now, on my calculator, I get 85.33333. And as several of you have determined, if you round off an answer in WebAssign, it's going to be wrong. What is 0.3 repeating? How would you write 85.3 repeating as a mixed number, let's say? What's 0.3 repeating as a fraction?
Is it 1/3?
It is. What's 0.6 repeating?
1/6.
No. 0.6 repeating would be 2/3. You see it?
Yeah.
Okay, yeah, y'all want to have those memorized. They come in handy. So this is, let's see, 500, or excuse me, 85 1/3 times. Okay. Inverse variation. Now, whereas with direct variation, the variables went up together and down together, inverse variation works a different way. Let's talk about that. Is there anybody here that of course, I don't know now, maybe you don't, but back when we were in normal school, that you went and got a, let's say a latte on the way to school every day? Anybody do that? Any coffee drinkers there?
Yes.
Okay, so what did it cost you roughly?
Like, do you want me to include like the change in
No,
it too?
just approximate it, like to the nearest dollar.
Probably like $6.
$6. Okay, so let's see the cost, $6. And so how many of those a week did you purchase?
Probably like 3 times a week.
Okay, so at $6 you purchased 3 per week. Okay, what if the price went up to, let's say, $8? Would you still get 3 a week?
No, definitely not.
Would you get any?
I would probably reduce it to like 1.
Okay, all right. What if they were $10 a week, or $10 per latte?
Then I wouldn't do it at all.
How about if they were $9?
Probably not at all.
Okay, okay. So let's go the other way. What if they were $4? Would you get more than 3?
I would probably stick with 3.
Fine. What if they were $2?
Then it would go up.
Like how many do you think you'd get?
Maybe like 4 or 5.
4 or 5. Okay. What if they were $1?
I would get 1 every week.
1 every week or 1 every day?
1 every day.
So 5 days or 7?
5 days.
Okay. What if they were free? Would you be one of those people? Have you seen those hats that have, I think they've got a spot where like you put beer cans or something, but would you put like lattes there and have a straw going to your mouth, or maybe just intravenously directly? Would you do that?
Yeah, probably.
Okay, so my point is, in this situation, as the price went up, she was willing to buy less and less. As the price went down, she was willing to buy more and more. So an inverse variation, when one goes up, the other goes down. When one goes down, the other goes up. Direct variation, they go up together, they go down together. Inverse variation, as we just explained, one goes up, the other goes down, one goes down, the other goes up. Okay. Third kind of variation. Joint variation. Y equals K X Z. Do any of you have a joint checking account? Do you even have a checking account? Yeah. So you have a debit card?
Yeah.
So that debit card's tied to a checking account, isn't it?
Yes.
Okay. Are you the only person on that checking account?
Yes.
Do any of you have a checking account that you share with somebody else? Like maybe you're married, you and your spouse. Anybody? Nothing? All right, fine. I have a joint checking account. What does that mean? There's 2 of us sharing the same account. Okay, so there's more than one person on that account. Joint variation, notice that on the right side of the formula, we have more than one variable. Okay, so y equals k x z, let's say. That's joint variation, where there's more than one variable on the right side of the formula. Okay, where are we here? Oh, here we go. Okay, This says oil storage. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The variation constant is 23.5. So in this case, they're telling us the variation constant is 23.5. Not only did they mention it, they told us what it was. Find the number of gallons that can be stored in the cylindrical tank shown. All right, let's see here. It says the number of gallons of oil that can be stored in the cylindrical tank. So we're going to let G equal number of gallons. Varies jointly as the height of the tank. So H is going to equal the height of the tank. That's supposed to be a G there. And the square of the radius of its base, R, is going to be the radius of base. And then, of course, they told us the constant or the variation constant. Okay, now I'm going to draw a picture here. I'm going to attempt to anyway. So we've got this tank. And we are told that this dimension is 20 feet. And this dimension is 15 feet. Okay, so they want us to find the number of gallons that can be stored in this cylindrical tank. And it says that G, the number of gallons, is varies jointly. So we've got G equals K times the height of the tank and the square of the radius. So G equals KHR squared. Any question where I got that? Okay, G is our unknown. K is 23.5. What's the height of the tank?
20.
20. Careful. What's the radius of the tank? Do you remember?
Is it 15 or 7.5?
Which one is it? Okay, tell you what, here's a circle. What do you call the distance all the way across the circle?
Diameter.
What do you call from the center to the edge?
Radius.
So it would be 15 halves or 7.5.
Okay.
Okay?
Yep.
So the radius is half the diameter, or the diameter is twice the radius. So I've got 23.5 times 20 times 7.5 squared. 23.5 times 20 times 7.5 squared. And I get 26,437.5 gallons. Any questions about that? All right. We're going to look at.
I do.
Yes.
For the joint variation problems, will they always give us the K?
No, they won't necessarily.
So,
But they'll
so what
always,
would you do if they don't?
they would have to give you everything else so that you could determine K.
Okay, so they
They're
give
always-
you the G instead of the K.
Yeah, they're always going to give you everything but one variable so that you can solve for that one variable. If they don't give you K, they would have had to give you everything else so that you could solve for K and then go on from there. Good question, though. All right, now, we're going to look at a verbal description, translating it into a formula description. This says, and then we're going to write out the formula. A varies directly as the square of P. A varies directly as the square of P. Again, K wasn't mentioned, but it's there. All right. This says Z varies inversely as the cube of T. Z varies inversely as the cube of T. Any questions there? All right. C varies jointly as X, Y, and Z. C equals K times X times Y times Z. Don't forget K. K is always there. Now, we're going to get a mixed variation problem. It says P varies directly as the square of A and inversely as the square, excuse me, as the cube of J. So P varies directly as the square of A and inversely as the cube of J. So P equals K A squared over J cubed. So we've got direct variation and inverse variation in the same problem. Okay. Let's see. M varies inversely as the cube of N and jointly as X and the square of Z. M varies inversely as the cube of N and jointly as X and the square of Z. All right with that? Now we're going to go the other way. We're going to write the formula and then put it into words. This says R equals KT. So R varies directly as T. Questions there? Okay. B varies inversely as H. D varies inversely as the fourth power of W. And how about this one? P varies directly as M and inversely as N. Now, you've got three kinds of variation: direct variation, where they go up together and come down together; inverse variation, one goes up, the other goes down, one goes down, the other goes up; and joint variation, where you have more than one variable on the right side of the equation. I want to remind you, K is present in all three forms. Okay, K is always on top. So you're going to want to have these three general forms memorized, because you don't know which kind of variation they're going to give you. All right. So this is Tuesday. Tonight's homework, section 8.9 in the chapter review. Tomorrow, Wednesday, we'll have a review session during our Zoom hour. Thursday, no Zoom meeting during regular class time. You just take your test. All right. Anyway, I'll be back at 1:15 today with an office hour if you have any questions. Otherwise,